So this is the answers to the 5.2 extra acids and bases. So extra acids and bases questions for the triple scientist. First off, they're the extra bits that you guys need to know, and you will be taught that are a little bit different than the rest of the year group. Okay, not many, so it'll be quite a quick video. Just some common Gcse keywords that you might come up with and you might need to understand. Then on here is just some common keywords that occur at Gcse, some revision tips, and then there's the knowledge organizer, and after the knowledge organizer is the review sheet, but there's another video for that if you needed to watch it. Okay, and then there's some questions to kind of test yourself, some key questions. You can make little flashcards, stuff like that, to test yourself. Okay, and there's the answers to them questions. So the first one, I kind of split it up into two sections. It says, describe the similarities and interactions of ethanoic acid and sulfuric acid with metals, carbonates and bases. Describe and explain any differences observed. You should include relevant equations in your answers. So the first thing I kind of did is break it down, okay, into kind of like key facts. So ethanoic acid got pH about 4, sulfuric acid pH about 1. This will partially dissociate. So if you add ethanoic acid, this is the chemical symbol for ethanoic acid, and it would partially dissociate into CH3, COO minus plus H plus, okay? Whereas this sulfuric acid will completely dissociate, okay? So sulfuric acid looks like that. Okay, and what we'll end up to is SO4 2 minus plus 2H plus, okay? Completely splits into its H plus ions, which is what causes something to be acidic. Ethanoic acid, slower rate of reaction, sulfuric acid, quicker rate of reaction. There'll be a lower temp rise in ethanoic acid, and there'll be a higher temp rise in sulfuric acid. They still react with metals, carbonates and bases, both of them, but the reaction will be a lot slower on this side compared to this side. Then just a picture, and it says pick from the words what that represents. That's corrosive, and then a fill in the missing words. So hydrochloric acid plus sodium hydroxide makes sodium chloride plus water. Neutral is green. Okay, then you've got a pH scale, kind of readings and a graph to show it. The next little bit then, which I've missed out in terms of writing, is with 3 marks, add the points, okay? So they're the missing points, and then you draw it on and kind of connect it up, okay? 3 marks for that, so be careful you don't miss them, okay? It says using the graph to represent how it is dilute, okay? So 25 degrees is 25 centimetres cubed is where the volume is the same, okay, on pH 7. So you're looking for something on pH 7. Okay, suggest 3 changes you can make to make a pure salt. Add known volume of acid to alkali, repeat with no indicator, evaporate water off and leave to crystallize. Then it says, bit of information. Okay, use this information to calculate the concentration of sodium hydroxide in solution. Okay, so you are given the volume, okay? You're also given the mass and the MR, okay? So the first thing I would do is work out the moles using mass over MR, okay? And that will work out the moles. And then you use this equation, moles divided by volume. So you've got 0.005, that's one too many zeros. And then you divide it by 250, but divide that by 1,000 to make sure, because that's in centimetres. You want to get it in decimeters, and then that is your overall answer, okay? That's quite a lot to do for 2 marks, okay? Then they set up a titration. You will need these on the next page, okay? So just be careful of that. Then there's a bit of an equation, and then there's 3 titrations. Really good titrations because they're all within each other, okay? So the first thing I did then, this is 4 marks. It says we want to calculate the number of moles of hydrochloric acid, and then use that to calculate the concentration of sodium hydroxide solution. Okay, so it's a bit of a different setup than before. Okay, so working out the volume of hydrochloric acid I did first, so I add these 3 up and then divide by 3. Okay, that gives me 22.5. Okay, then I looked at a ratio of 1 to 1 to work out and I consider the fact that they'd already told me on the previous slide that the concentration of hydrochloric acid was 0.2, okay? So then I worked out the moles. Using the volume I've just worked out, the concentration was from the previous slide, 0.2, so that concentration times my volume works out the moles, okay? So that's what the moles worked out to be here. They are in a ratio of 1 to 1, okay? There's no numbers in front, a ratio of 1 to 1, okay? So you are saying the moles of sodium hydroxide is the same as the moles of hydrochloric acid, okay? So then I know my volume again from the previous side of sodium hydroxide, so then I can do the moles divided by volume equals concentration. Be careful that you divide that again because it needs to be in decimeters cubed by 1,000. Next question then, looking at a kind of like flow diagram. Name the pungent gas is always going to be ammonia if it says a minging gas. Smelly gas, and looking at the red litmus paper turns blue as well, okay? Give the chemical name of the blue precipitate formed. Sodium hydroxide plus copper chloride, they're going to kind of work to displace each other, so you're going to end up with copper hydroxide and sodium chloride, okay? I don't know why there's a little line there shouldn't be. And then top, swap, drop to work out the formula of this, okay? They tell you it's 2 plus, so top Fe2OH1, swap Fe1OH2, and then drop Fe1OH2, okay? Be careful of that because there's 2 elements, you need to make sure they go in a bracket. Next one then, universal indicator turns red in sulfuric acid, orange in ethanoic acid. What does that tell you? Well, sulfuric acid is a lot stronger of an acid than ethanoic acid. Both react with magnesium rib and form hydrogen gas. State how the reactions would differ. Sulfuric acid would be quicker and then be a higher temp rise. Okay, give the test you would carry out to identify hydrogen. Let's blinked, squeaky. Another one of these flow diagrams. So the first one we're looking at is A. So again, if you're really struggling, box it up and write it out like that. So you'd have ethanoic acid plus A goes to sodium ethanoate plus CO2. Okay, so this plus CO2 indicates to me that it's going to have to be a carbonate. So A is going to have carbonate in it. And then the sodium is the first name, so it's sodium carbonate. Okay, same kind of thing then. You've got ethanoic acid plus magnesium. Okay, so then that's going to be magnesium ethanoate. Okay, give a reason why ethanoic acid reacts less vigorously. It's a weaker acid, partially dissociates. Ethanoic acid form an alcoholic drink such as wine is left exposed to the air. Give the name of the compound in the wine which turns into ethanoic acid. That's ethanol. Okay, that's another topic. Okay, so looking at this question, give the volume of acid required to neutralize them both. Okay, so they're both at 25, so it's going to be 25 degrees. Maximum temperature rise, okay, for acid B. Now be really careful of this. It starts at 23.5. Okay, if you look there, it starts at 23.5, and then it goes up to 25. So taking them away from each other will give you 1.5. Okay, state which acid is stronger. A, because there's a larger temperature rise. Describe what indicator could be used to find the exact volume. Indicators change colour based on acidity or alkali ratio. Closer to neutral, the substances turn green. So then you could, looking at the burette, you can add in and work out what colour, when it changes colour, to know how much acid you need to add.